Let me share my screen. All good with the screen here?
Looks good.
All right. Yay. All right. So welcome to the fourth Temporal Java SDK Workshop. Yeah, so we've done these before. If you're here for the first time, welcome, or everybody welcome, of course. But if you're here for the first time, we do have all the previous workshops, the first three recorded. They're on our YouTube channels. And I'm going to put this in chat real quick. Again, this link is kind of important. This is the GitHub URL that basically contains the code and all kinds of little documentations for every workshop that we have done so far, including this one. And yeah, so here you can find basically every single, everything that we're showing. So for the fourth one, we got some more stuff going on. First, we got to do an intro, and Dimitri, our SD for the Java SDKs, I thought it would be great to kind of give an update on the SDK itself, talk about roadmap, whatever you want to share. That would be awesome. And the way these kind of workshops go, they can go, typically we have 90 minutes now. If they go over, if there are more questions, it's fine. I'm sure others will stick around for that as well. And the way it works is like we just look at a bunch of code. We run a lot of stuff. We try to break things, as you'll see in the first section. The second section, we'll talk about some, patterns or, quote unquote, best practices that we have kind of talked about and users have brought up and on the forum. Again, for section one, everything that we do here either has been asked before by some sort of community user, temporal user, or we have kind of asked ourselves because we're, all of us are in the same boat in the end. And due to popular demand, or a user asked last time to kind of start talking in these workshops about SDK metrics. And so in this one, we're going to just kind of do an introduction. There's a lot of stuff we can talk about this, but for this one, we're going to basically show an easy way to set that up SDK metrics if you want to get it started up and running real fast, and kind of look at some Grafana stuff and also some sort of worker tuning guide that also Dimitri has worked on, and it's also part of the documentation. So Dimitri, are you ready? I'll stop. Do you have anything to share, or you just want to talk?
Oh, no, I will not share the screen. Yeah,
okay.
I will just talk for a couple of minutes. So yeah, folks, there is quite a bit of changes in Java SDK in recent releases, and a little bit of probably annoying deprecations that may affect you, not may affect you, will affect you, because they happened in very central parts. They're mostly related just to the fact that we clean up either previously absent functionality, like we introduce it, or we clean up like a little bit of old configuration mess. And basically two things changed that may affect a lot of users is the way how clients are created. We realize that our old way of creation of client is a little bit intrusive for how many teams work. Our previous way of creating a temporal client was an eager connection that would completely fail with an exception if the temporal server isn't available. And we decided to switch the default strategy into a passive, like lazy connection on the first request. That's the reason of a bunch of deprecation around workflow service stubs. So please switch to the new methods, whichever are appropriate for you. I recommend to use just a lazy client for most setups. And if you really want to stay on the old behavior, there is a method for you that creates eagerly connected stubs and clients. Basically, the main driving force for that is a lot of requests like, hey, we really want to have a lazy client because we give temporal client or code that uses temporal client to other teams. to directly trigger workflows on temporal server. But the teams don't operate temporal, they don't understand temporal, and they don't want to be dependent on if our temporal server is up and down. They don't want their application to crash and start if the temporal that we manage is down. So that's the main request and driving force for this like super central core change in the API. And another thing is we really spend a lot of time polishing and working on search attributes. And basically last year, there was a lot of work on observability, on Elasticsearch, on server, and now on SDK. And right now, like I believe in release 1.9, the Java test server supports fully search attributes with proper validation, etc. So Java test server is not as permissive as before. It will basically fail more or less the same way on failure scenarios as production temporal server fails. So there is a little bit of migration to make it happen. So right now, like when you use search attributes with a real temporal server, you need to register them. Right now, you need to do the same with test server. You need to specify the name and specify the type of search attribute on the test environment. To basically make it possible for all the nice validation to happen for you for the test environment. That's basically two main changes that I want to talk about, and that probably affects a lot of users and may become like reasons for like migration annoyance. Also, you maybe noticed that we started to make Java SDK releases much more often. Like previously, we were sticking to once a month releases. Last month, there was like 3 releases inside 1 month, basically. Don't get spooked by that. It is not a sign that there is something unstable in the last releases. It is just we are basically onboarding new clients with big different use cases as we saw before. And we saw problems with that always were in temporal code base, but now they become more prominent and more clear, and they get fixed. So it's not about instability of any like last releases. It's just a lot of bug fixing work on basically old legacy code in Java SDK clients. That's pretty much it that I want to talk about. Tifa, go ahead.
Awesome. Thank you so much. Anybody has any questions for Dimitri? Nope. Quiet crowd. All right, so let's thank you again, and all right, so let's get now to the workshop part. So again, we're going to look at code. We're going to run code. Feel free to interrupt me anytime. If you have any questions, speak up, or if you want to put them in chat, we have people here that is going to help you there as well, and I'll do as well. If there are any questions in chat, whenever we maybe switch sections or come and to the end of one section, we can also read them out if you want to ask them yourself. But yeah, let's make this a little bit interactive and go from there. So the first section is number 1 is I wanted to bring up some stuff that comes up. Either it comes up often on the forum, or some people have asked any questions. And one thing that comes up quite a bit is, how do I deal with error handling when I execute things in parallel? So for example, activities, or in this case, what we're going to look at are child workflows. But basically, with Temporal, of course, the Java SDK, you can start multiple activities or child workflows in parallel, and then you can, of course, wait, see what you want to wait for all of them complete, you want to wait for the first one to complete, and things like that. But just to start showing code, this thing is in C4S1. So the way this package structure works is the first thing is like chapter 4, which we're on right now. and then it would be section 1. And also you have in the README here, which we're also look at, you have links to each one of the packages for each one of the examples. So let's go ahead and take a look at the first one. We're not starting this from scratch. This is the fourth kind of workshop, but if you have, again, any questions that you might feel confused or anything like that, feel free to just speak up and we'll stop and kind of, try to explain everything so you fully understand kind of what's going on, or if this is actually going to help you. But in any case, in this case, we have a workflow, and I'll make this a little bigger, called some main workflow, and this is the implementation and implements the workflow interface, and basically has two child workflows, and which is the child workflow 1 and child workflow 2. Each one has its own child workflow options, its unique workflow ID. Since we don't specify the task queue and the namespace, it's going to inherit that from this parent workflow as far as whatever you specify on the client side when you invoke it. And they have two run timeouts. You remember workflows have two really timeouts. One is the run timeout, which is the maximum amount of time for a single workflow execution. In this case, we set it to 10 seconds. You also have workflow execution timeout, which will include retries if you do specify workflow retries. But again, that's not something that we recommend in almost all cases to be done. But the thing about this one is we want to start this child workflows in parallel. The second child workflow, which is child workflow 2, and we're using the typed workflow stubs here, has a runtime out of 2 seconds. And if we look at the implementation of this child workflow, it's actually very simple, but there is an issue. It's going to sleep for 3 seconds. Because the runtime out is controlled by the temporal server, sleeping here in this child workflow 2 for 3 seconds, and it's got a runtime out set to 2, it's going to time out this workflow execution. So what we're doing then next is we're creating a list of promises, and in this list we're adding async procedure. We're using procedure in this case because neither were child workflows. We care about the result. You can also here use async function as well. It doesn't really matter. But if it doesn't have a return type, then in most cases, we can use the async procedure. We're adding these two promises into a promise list. And then we're basically saying promise.alloff, which is at this point with this get here is a blocking call on line 38, which is going to wait for all promises to complete. Now, these child workflows, or the promises that we're actually completing in this call, can succeed or they can fail. And alloff is going to wait for all of them. Now, the important thing is here that in case of failure, in which case our child workflow 2 is going to fail with a timeout, child workflows are always going to deliver child workflow failure. So in this case, we can catch it, and then we can go through our list. Basically, we loop through a list of promises. And there's two methods here that I just wanted to show with the sample. Number one is promise.getFailure. If promise.getFailure is null, we basically is not null, then this promise failed. And you can actually, get information, for example, failure.cause and things like that. If getFailure does return null, then you can pretty much be sure, okay, this promise is completed. But again, I wanted to show there is also promise.isCompleted method, which returns true in this case, in the case promise is actually completed. And all we're doing here is basically adding. So from the two child workflows, both give us a result, but we handle the failure really here from the second one, which will time out and adding to the result only the returns of the promises that I actually completed. And again, we got a little starter here that just starts the workflow. It's nothing, we've seen those many times. I'll start to run and make this bigger a little bit. So this is going to start the two child workflows in parallel. And hopefully, yeah, so we were able to handle the promise, which is as a timeout failure. And if we look at our workflow here, we see the child 2 has timed out. We can also look at the workflow history that the last event in this history is workflow execution timed out due to the workflow run timeout that we've set. And we were able still, to get a result here from our child workflow promise that has completed. So just remember two things here, if you care, is how to deal. You can still catch a child workflow or activity failure on promise all of or any of .get, and you have to loop through the list of promises, and then you can check if he has failed or he is complete. All right. So any questions so far about the first thing in our section 1? All right, so the second one is kind of fun. And we always talk to our users and give them pretty much this page. And let me kind of open it up. And this page has some workflow implementation constraints. This has to deal with a lot of different things. So when you're writing your workflow code, your orchestration code, you have to worry about these things called determinism and everything we kind of went over in the previous workshops. But regardless of that, there is some things that you have to worry about. And one of the things that we always tell users, of course, okay, don't use system time in your workflow code or some library that utilizes system clock. Always rely on the actual clock provided to you by the server by getting the time from that. But another thing is Java threads. And Temporal SDK does provide abstractions for native Java thread. And one of the things that we've seen just now in the first thing was this promise instead of using the futures. But the question is, okay, but what happens actually if I use Java thread? Because a lot of times, even if we look at these constraints and try to write our hundreds or thousands lines of code, stuff like this, it might happen. And maybe we're not actually aware of it because some other library that we might be using could be causing or using some Java thread and blocking. But the reason not to use Java threads is because you want your workflow execution to be able to continue and make progress and not be blocked by your actual workflow code or any instructions to use native Java threads. So for this, I just wanted to show you is we actually want to see what happens if we do this. So in this workflow, we have a C4S2 workflow that actually just calls thread.sleep straight in it workflow code. And if we, let's go ahead and start running this. Well, one thing that I wanted to show is in the starter is when we start this workflow, we actually set a runtime out of 45 seconds, all right? So this means that, you know, whatever happens, the server is going to time out this workflow in 45 seconds. So let's go ahead and run this. And the thing that we're actually getting is this potential deadlock exception. As you can see here, I'll make it a little bigger. So basically, the SDK is saying we have a potential deadlock exception, workflow thread didn't yield control for over a second. So we're enabling a workflow code to make forward progress. But one thing I wanted to show, and which is kind of important why you shouldn't be using Java native threads, is we cannot catch this exception in our workflow code. And Dimitri actually helped me with this yesterday to kind of start and to understand is that, this is actually not executed in the workflow thread. And Dimitri, if you want to step in and kind of explain if anybody has questions, but basically, when you start using, for example, Java native stuff and start blocking the workflow threads explicitly, there isn't very many ways to get out of it. Basically, you cannot, well, we'll show one that there is, of course, with Temporal, but you can't catch it in your workflow code. You can't really cancel this workflow anymore. So the two things that you can do, you can terminate it if that's what you wanted, if you don't want to actually make the fix, or you can actually rely on timeouts. And if we look at, let's say, our workflow here, we see that it has actually timed out. So even though we weren't able to deal with, in this case, with this potential deadlock exception, we still can rely on our workflow runtime on 45 seconds. Now, in a lot of cases, you don't specify a workflow runtime out. And for long-running processes, that does become an issue where you cannot rely on that and you don't want to terminate. One thing though that we can do, and I'm going to start this workflow again.
Want to highlight, you can rely in terms of state management of the workflow. So server will be able to, for example, understand that the workflow took more than 45 seconds or more than your timeout, and just basically kill it on the server side. But there is no way to just kill a thread in Java. So for example, like that's one of the big reasons why users shouldn't be doing any threads stuff in workflow code, because nobody theoretically prevents you to write thread sleep and for the next month. Like, and thread will be waiting on this line for a month, and there is no way to kill the thread. So it will be just one occupied, taken from the thread pool thread that cannot do any useful work. So while server will enforce constraints and it will time out the workflow, and nothing will more be done to this workflow, client code can still, for example, just sleep for a month. That's why we try to like throw all of these potential deadlock exceptions, log them, etc., to make it visible.
Thank you. Yeah, but just to show kind of like we always talk about things like, you know, resilience with temporal. If I start this workflow again and I start getting my potential deadlock exception, and we can see our workflow is running, I can stop my worker, right? In this case, my workflow is still going to be running, and I can basically fix my error in my code, right? And so instead of thread asleep, I'm going to actually use the one that I'm supposed to do, and start my worker back up. And hopefully, you know, after the tap, you know, see we go and we have a workflow completed. So with temporal, even though, yeah, you can make this mistake and we can say, yes, this is an issue, you can't really catch it, you can't really cancel it, things like that. With temporal, you can still recover from pretty much any failure. So that's kind of like, and you see here, we were still able to complete and get the result, even in case, you know, our workflow had a bug and we were able to fix it right away. Another thing I wanted to show here actually is you can block the thread or block forward progress of workflow execution using thread.sleep. But what about this guy? Just while true. And this is a little bit different. And again, what I just wanted to see what actually happens here, and because this can also happen to you or happen in your code, it doesn't really matter. You can have an basically what this is an infinite non-blocking loop. And by well, later we will see actually with blocking, but non-blocking means we don't really execute anything. We don't run any temporal SDK APIs that actually block workflow thread. It needs to actually communicate with the server. So we don't invoke any activities, any child workflows. We don't create any timers. This is basically while true, and that's it. So in the workflow will not be able to make forward progress here as well. So if I go ahead and start this with just a while loop, let's see what actually happens. So probably we need to wait about 10 seconds, I think. And we'll kind of try to explain. Yeah, and in this case, we actually are getting an unable to acquire lock exception. This is not potential deadlock exception. Basically, what happens in this case is there is a 10-second workflow task timeout, which our code basically, our worker can never complete because of this infinite loop that we have here. So on the server side, the server plays the workflow task onto the task queue. Worker picked it up, started executing our workflow. It cannot really, you know, communicate back that it has completed because of our loop. The server then places another workflow task thinking, hey, this one hasn't completed. I'm going to put another one onto the task queue. The same worker picks it up and says, look, and I got all this from Dimitri, by the way, so thank you, Dimitri. And the worker basically said, I'm already working on this, and throws this unable to acquire lock exception. And again, the same thing with temporal. You can fix this, you can stop your worker, you can fix this while true statement and fix your code, maybe test it or debug it or whatever to see what's going on. And you can then continue, start your worker back up and recover from this failure as well. But just in case you get this to a potential deadlock and also this unable to acquire lock exception, they usually.
But question, you do get potential deadlock exception in this case too, correct? Because you should. If you don't, I need to take a look at it.
I did not see it in the stack trace, but we can double check and look at it after. Yeah.
That's strange. I will take a look at it. Because I would expect this thing to give both potential deadlock exception, and because thread is never released and it still works on this workflow, we cannot take a new workflow task before it's killed. So I would expect both here.
Awesome. All right, we can take a look. Next thing I kind of wanted to kind of talk about are signals. And for this, we get to, question is, do you ever want to disable signals? And why would you ever want to? And this is kind of not like a question that does come up a lot, but it is a little trickier. I wanted to show one situation where signals could potentially create some sort of issues, especially if you expose temporal APIs to end users. So typically our SDK has two parts, right? It has the client API, which you use for in these things that all over the place we call starters. I'm sure that I stopped. Yep, nothing is running. But in this case, what we have is two workflows, right? One workflow is basically just sleeping for 50 seconds. And the other workflow is sending it signals. So it's going to send it 10 signals using external workflow stub, which is going, this workflow stub to use if you want to communicate, for example, send signals to an existing workflow execution from within your workflow code. At the same time, in our starter, we're also sending from the client side signals to it. Now, the two different signals that we're sending to this workflow is one is called the payload is from client, and the other one is from of course the workflow. But one thing that I wanted to show is, I think here we don't really handle this signal at all. There is nothing in our workflow code which just sleeps for 50 seconds that actually takes this payload and updates the workflow state. So basically what the situation that I'm trying to kind of show with this example is where you expose, let's say, for example, the temporal SDK API to some clients. Maybe you put it behind a REST API exposed by users, and inside you call, like, you signal your workflow. You do a signal with start, for example, which is typically what people do. And what if somebody slams the REST API with like thousands or of signals? One thing that I wanted to show, and just to kind of run this code, and I have to look, I always put myself little notes of what to show and what to not show. But one thing I wanted to show is, let's see if we can look at our web UI now. We have two workflows running. The first one is the one that sends signals, right? So it's just going to send signals on an interval basis. And child workflow 2 is the one that actually receives signals from both the child workflow A and the client. So you can see here, workflow execution signal from client, and then there should be also ones that say here from workflow as well. If you see that each signal, temporal records every signal into workflow history. So regardless if you actually have a signal method in your workflow code or not, or if you have 1 or 100, every single signal that is sent to this workflow execution is going to be recorded into history. So one question comes up is like, well, is that a problem? And the answer is really yes, because as we talked about in previous workflow, number one, you do have a 50K history limit. So once this number reaches 50,000, not only before that, this workflow execution might slow down, but the Temporal server is basically going to kill this workflow execution when it reaches 50K. So you could potentially have a rogue client that you might expose to that sends 60,000 signals to your workflow and basically kill your workflow. Now, the long-term solution for this, and I think I have it written down in this README right here, is, and this is something where that I confirm that this is something that should be added to Temporal, is something called an update feature. So basically, currently, what I'm trying to say, not yet, Temporal does not have a way to reject an update meaning a signal, an external signal that represents a possible update to a workflow execution or the data or the state of a workflow execution. We don't really have a feature to reject this. You can, of course, reject it in your code by, for example, in signal method like we have here, just setting it and not doing anything about it, or just not doing anything in your signal method handler, really. But at the same time, these signals will be recorded. So the long-term solution for Temporal, that hopefully will come soon, is going to be to actually be able to reject an update without writing it to workflow history. But what can you do now? And I know, probably Dimitri is going to hate me for this. And I tried to actually figure out how to do this. And it's not something that I recommend people to do. This is just basically hacking, and it's bad practice, more or less. But I just wanted to show that we can actually do that. And let me make sure that this guy's completed. Yep. So one thing that we can do is using interceptors. And interceptors are an advanced concept. And we will actually, in one of the next workshops, dive deep into interceptors. But long story short, with the Temporal Java SDK, you have the ability to intercept certain things. You have things like client interceptors, where you can, for example, as I will show, will actually intercept the client call to signal this workflow. But because our workflow actually also receives signals from external workflow stuff from within workflow execution, we also have to block that. So let's, the first thing that we're going to do is try to block the client calls. And for that, we have this workflow client. When we create our client, we want to create workflow client options, and we're going to set a client interceptor. And this thing is a client interceptor. And what we're going to do is basically intercept any client signal methods. And we're just going to bypass the actual call and just return some dumb nothing. So basically, this is bad practice. This basically, any signal that comes to this is going to be simply ignored. But let's see actually what happens. And in the starter, we can set our service and options here, and we can run this workflow again. Let's see the starter. Right. And let's see now what happens in our web UI. Okay, so here is child workflow 2 that receives signals. So now we should no longer see these signals from client. As you can see, even though our client is sending signals from to this workflow, we have managed with interceptors, bad practice again, but it's possible to, so basically kill all the signals that might be coming from client to the front-end service for any workflow execution in this case. But we still have these. And for that, what we can do is Temporal SDK also provides workflow and activity interceptors, worker interceptors. And for this, we can go actually down here when we create our worker and create worker factory options. And in our worker factory options, we can set our worker interceptor. And our worker interceptor has workflow and activities. In this case, what we actually want to do is, is actually get our workflow outbound calls interceptor, because that thing, in this thing, we can override a method called signal external workflow, which is actually going to intercept the call from our external workflow stub this sends, well, basically, I'll show you what this is going to intercept. Basically, external workflow stub signal, because set data is the signal method of this particular workflow. Long story short, we can disable it here in a very ugly way again. But again, with interceptors, what we can do is disable these signals too. And just to show kind of get end on this, the last run. In this case, our workflow 2, if we see now, is not receiving any signals whatsoever. So again, not a thing, it's going to be fixed for, with the update feature or being able to reject update feature in the future. But that's something to think about. So I mentioned this not to use the solution of disabling signals to interceptors, but just kind of more or less to let you guys know that you have to be careful when you expose the temporal APIs, client APIs to end users or somebody that you don't trust maybe, or can actually do some damage to your workflows via this APIs. All right, so that's it for that. Okay, so let's see where are we now. We are now at, this is a feature that was added not too long ago as part of the temporal on the server side, and you can actually start using it in your code as well. There is, of course, limited type of use for temporal cron. Of course, you can start a cron execution that executes maybe every minute, once per hour, and things like that. Cron itself is limited and is undergoing currently a lot of changes, I think, within our teams, and a new way of defining crons and dealing with crons because of some of the limitations currently is going to be improved drastically in the future. However, it is what it is right now. But one thing I did want to show that maybe not a lot of people kind of maybe have used before is the ability to actually set the time zone in your, where is this thing? Oh yeah, here, in your cron workflows. And why is this even important? Well, the reason for this is that temporal server runs on UTC time. And by default, when you set a cron schedule that you want your workflow to execute at, let's say, 10 minutes after 5 every day, it's going to be UTC time 10 minutes after 5 or 5 minutes after 10 in this case. But a lot of times, we don't want UTC time, and we want actually to represent our local time zone and allow the cron feature to actually convert this, using our time zone to convert this cron schedule to local time. So this makes more sense to our users. This doesn't bring in confusion as far as time zones and things like that. So just to show, with temporal crons, you can set, of course, you set the cron schedule in workflow options. So when you start a workflow execution, you define your workflow options, and one of the things is the cron schedule. So this is the typical way of just defining a cron tab. Another thing that temporal does support is this robfig cron library. So you can actually create an interval. So you can say, I want every minute. And this is also fully supported by the temporal server as well. So you can define the express schedule like this. But you can also set time zones. And here I put a link to all the different time zones. So if you're interested, you can browse through that. Now with time zones, there are 2 ways. This robfig cron supports 2 ways. This is kind of like the more unofficial way, but just saying TZ equals. Now the time zone goes before the actual cron definition. So you have to either say TZ equals, and in this case, America, New York, so let's say for Eastern, or you can use kind of more the quote unquote official way of defining time zone in your cron definition, which is the cron_TZ way. And this is fully also going to be already converted for you. I don't think I need to run this. I mean, if you guys want me to, that's fine. You run it yourself and you can see the difference. But let's say if you run this on your own, do this, for example, and you will see that is UTC time actually, or set your time zone here and run the same cron schedule. You'll see that actually will be converted. Another thing that I wanted to show is, for example, predefined schedule. So you can say at monthly, which is going to be once a month at midnight and of the first of the month. All right. Any questions so far?
One question.
Go ahead.
Yeah. So like we have written interceptors for each workflow, right? Is there any way we can write the interceptors for activity? So basically, I want to capture the status of each activity, like its start status, and at the end, I just want to log some statements. Is that possible?
Yeah, you can intercept
Yes.
the activity. Oh, go ahead, Dimitri. Yes.
There is activity inbound interceptor where you can intercept an activity execution and, for example, add your own log statement before the activity execution.
Okay.
Just I usually give a like warning to people who are asking about interceptors. Keep in mind that interceptors as fairly advanced feature. They're mostly designed with not a comfort of users in mind, but more flexibility for framework writers. But specifically, this thing should be fairly simple. You just need an activity inbound interceptor and override one method.
Sure. Okay. Sounds good. Thank you.
Basically, activity interceptors work on like 4 different levels. First level, it's when you send a message from a client to the server. So it intercepts a client request to the server. Second, it's what called workflow inbound interceptor. It intercepts right before the workflow actually starts executing something, signal, workflow method, etc. So it's something that inbound from the server to the workflow. There is workflow outbound interceptor that intercepts from the workflow into framework code, for example, triggering an activity. And there is an activity inbound interceptor that intercepts something from the server to the activity. So there is this 4 levels, and you need the basically simplest one, activity inbound.
I see. And there I can capture the activity ID as well, right?
Yes, I think you should have access to activity ID. Yes.
Yes, you should be able to.
You have access to activity info there, which has an activity ID.
Yeah.
I see. Okay. Thank you. It will be great if you have any documentation link for this. If you can paste it, please.
Yeah. Also, just to add this, like in our samples, we do have an interceptor sample that shows all those interceptors as well.
I see. Okay.
Yeah. So if that helps, if not, well, we can add. Go ahead, Dimitri. Sorry, I interrupted you.
Yeah. Our intercepts of documentation is limited for a reason. We realize that they're not the prettiest one, and we kind of want to slow down people from actually using them. So because they are fairly ugly. But you have a sample for interceptors.
Okay, thank you.
Any other questions about it? All right, we're ready for the next thing. All right, so the last thing in this how-tos, whatever is that, I just wanted to kind of, we have example of error handling, and typically we have samples like this shows, okay, my activity fails, I'm going to catch it inside my workflow code. But we don't really have like a bigger sample, for example, something like multiple layers of error handling and showing really off error propagation. So what I wanted to kind of, just have a little fun with this, I think this is the C4S5. So what we have here is basically, I'll just put it in only one class, all the interfaces. Usually I'll do multiple ones, it makes more sense. But for this case, what we have is we have basically a workflow that calls child workflow A. Child workflow A calls child workflow B as a child workflow. Child workflow B calls child workflow C. Where is child workflow C? Yep, and child workflow C implementation actually calls an activity that fails. So we have basically an kind of scenario where you have multiple kind of layers where this particular activity failure that happens in child workflow C has to propagate back to child workflow B, or its parent has to propagate back to child workflow A, its parent has to propagate back to its parent, which is my workflow, and we want to handle all that. And with Java, it's a little bit having to get used to, but once you kind of get the idea, is I think you know, and this sample maybe could help. The way this works is, number one, we already talked about this, right? Activities after retries, of course, which activities have default retries. If an activity fails after, you know, X number of retries that you specify, it's going to always throw activity failure, all right? And the activity failure is going to have an application failure inside of it as a cause, which will have the original failure, which in this case is going to be our timeout exception, I believe, because we're timing out this activity. Or I don't know, wait, I gotta see the implement. No, we're actually throwing an MPE. All right, so our activity throws MPE, is going to retry, and once the retries are exhausted, is going to deliver activity failure to its parent with the application failure inside of it. Now, that child workflow, which is child workflow C, is going to actually raise child workflow failure. Child workflows always, you know, if you define child workflow retries, which again, we shouldn't, but if it fails, it's going to throw child workflow failure. So basically what we're trying to do is we're actually calling here child workflow, my child workflow A, and what we're catching is the child workflow exception, and this is going to be the propagation. So child workflow B failure, we can get it from the cause. Then child workflow A failure, we can get from the cause. And from this, from C, we can actually get the activity failure. And from the activity failure, we can get the application failure that includes the original message, which get type should be null pointer exception, and the original message should have propagated, which is the simulated from the activity. Another thing just to show, and not only can you do this within a workflow, but what we're doing here is to show how they can also propagate back to the client. So once we have actually shown that we can handle all this error propagation from, you know, deeply nested activity failure inside of some child workflows execution, we're rethrowing this. Basically, we're failing this workflow. And we want to actually see, can we actually do the same thing on the client itself, client being the actual workflow where we have started the workflow execution to begin with. So let's just kind of run this if we want to. So we're getting all those worker logs. And okay, so number one thing here on top, we can see that we were actually able inside our workflow, and make this a little bigger, able to capture the original failure of the null pointer exception, which happened inside of the activity, and you can recreate it from the type. And we actually got from our workflow that started again a child workflow, that started a child workflow, that started a child workflow where the activity failed. We were in the top level able to actually get the original null pointer exception that happened inside of the activity. On top of that, if you see on the bottom here, inside of our starter, where we actually caught a workflow failed exception. So when this exception actually got delivered back to the client, it is of type workflow failed, because our, if you look, let's take a look at our, yeah, so you see my workflow has actually failed. We got a workflow failed exception. And from this, again, we can use error propagation. If we know actually how things work, is we can get the workflow failed exception cause, which is going to be our child workflow A failure. Its cause is going to be B. Its cause is going to be C. So we're kind of propagating back through the error chain. Its cause is going to be activity failure. Its cause is going to be application failure. And this application failure is going to have the original exception, which is our MPE from the activity. and the original message, which is simulated from the activity. So if error propagation, thankfully, even like in this case, works the same way as it does on the client, except here you would catch workflow failed exception instead of within workflow, a child workflow failure is going to be delivered to your workflow code. All right, any questions here? No, yes, no. All right, so let's stop with this how-tos, gotchas, breaking things. And one thing, this is the first time we're doing this. Now, there's a lot of patterns, and the best way to kind of start getting into this is more or less get on the forum, so community.temporal.io, and a lot of this stuff is documented within different questions, different forum posts and things like that. But I thought like maybe starting from this workshop, we can always introduce a couple patterns. This is just 4, but I kind of wanted to talk about this because a lot of times it's not only about things like low level, interceptors, handling errors, blah, 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 but it's kind of talking about real use cases and how you might approach these use cases using Temporal and of course the Temporal Java SDK. So in this case, let's see, look at patterns. Oh, I'm going to stop this guy here. Patterns. So this is the first one, polling. All right. So this is the same example that we have also in our Java samples repository. This is basically a copy, but this question comes up a lot. And let's see if I can open up this particular forum post. And this is basically the forum post that we have been kind of linking to a lot, to the community, and a lot of questions is where you have a third-party service. Now, this is not a service that you control, so it cannot be, for example, just an activity. And with Temporal, you can deal with that much better than you don't have to use polling. But these are situations where your workflow orchestration actually has to contact a third-party service, let's say a banking service or whatever, that you don't control, maybe via REST API or whatever the heck the situation might be. And you want to actually poll this service until it gives you a result. And with Temporal, there's multiple ways to do this, but basically the idea is that you have 3 different approaches depending on how frequently you want to actually poll. And the one, that I wanted to kind of talk about is this infrequent polling. What does this mean? And typically it's like 1 minute or more interval that you want to poll. One thing about this particular approach that's actually kind of cool is that we're actually going to use activity retries for this. And activity retries are not really recorded in workflow history. So you're going to have an activity started, and then it's going to have an activity completed, for example, with a count of retries that it has completed given on your retry logic. So reason to do this for infrequent kind of polls is you will not kill your workflow history, where later on, we're actually going to see an anti-pattern called busy loop, where we actually try to show how busy loops are, for example, bad. But the one thing about this approach that's important is to set the backoff coefficient to 1. So setting this backoff coefficient to 1 basically tells your retry options that it's going to retry every 60 seconds or every duration that is specified in the initial interval. So just with retry options alone, we can actually create poll some services. Yeah, so that's the one approach for how do you say polling. Now, if you have to actually poll like every couple milliseconds or something, typically you don't want to use retries, because this is actually going to go back to the, you want to limit the actual interaction of the server, and you don't want to slam your front-end service and use retries for this. And for frequent, the way we kind of have approached this is to actually, or recommend to do, is to use this actual polling loop inside of your activity. Now, the important thing about this activity, though, and we can run all these samples if you want to. I mean, it doesn't matter. You can run them yourself. Just let me know what you want to do. Is basically you want to have a while loop in here inside of your activity. You want to call your service, handle the error, and you have to heartbeat. And the reason for heartbeating for this particular activity, so you can actually, number one, cancel this activity if you ever want to, and it can actually provide progress information. And in this case, we heartbeat every time we check the service. We sleep for some poll duration amount, which can be milliseconds, and then we do this again until we actually get a result from our service and push it and reply back to our workflow. And one thing that it's important here is to set a heartbeat timeout. And this heartbeat timeout for this particular polling solution should be less than the start to close timeout by far. So your activity probably in this case has to heartbeat within 2 seconds. Let's say the call to your third-party service to get a response takes a second or so, and then you can heartbeat within that amount and do progress. The third way, which is kind of not really used, and is this some sort of periodic sequence. And this is also a sample. In this particular polling solution, and you can also read, the forum post, is either when you want to actually poll a sequence of activities. So you have multiple services probably that you want to poll, and you can maybe change the arguments between this particular polls, and you can use child workflows for that. A child workflow that executes 1 or 2 activities, and you can put retry options on your child workflow as well. And there is a solution here, or in our Java sample says basically the same code for that. But yeah, if you're thinking about polling, if you have some services you have to poll for success or some sort of result to come back, these 3 particular solutions, you can use them and apply them for your use case as well. The second thing I wanted to talk about is this recovery and fallback type of pattern. And I think this is here, right? Let me see just real quick what I have written for this. Okay, so recovery and fallback. And you guys know that, the Temporal Java SDK does have support for this sagas or compensation. And you can look up in the docs, and we also have a compensation sample in our Java repository. I mean, the samples repository. But basically, compensation is used to undo something that has already been completed. So saga is useful. For example, let's say one of my activities completed, let's say a withdrawal, and something that later on happens during my workflow execution, where I say, okay, I have to roll back this particular withdrawal that happened. And then I can use Saga to actually run a deposit activity and compensate that. Saga, it is what it is. Compensation is fairly kind of simple, the implementation, and I'm sure it can be improved, but that's one way of doing it. You can also implement compensation as basically try-catch blocks if you wanted to, but for a large workflow execution, it maybe makes sense to use the API that the SDK provides. But in this case, we don't want to recover something that already successfully completed. We want to actually recover from a failure. So the scenario that we're looking at is basically, if my activity A fails, I want to run activity B. If my child workflow ABC fails, in this case, it may be even under a certain exception type, I want to run child workflow B. So this is this recovery fallback. And one thing that I wanted to show is basically, yes, you can, as we've shown in the error handling, you can try, catch, execute an activity. An activity is always going to throw activity failure, and you can go from there. But I wanted, one of our users actually, and this is kind of cool, and start playing with it, actually created a very cool utility. And if you're here, please speak up if you're the guy, person that created this. Is basically they created this recoverable interface that makes this a little bit simpler. And not telling you guys should be using this, but let's show you as a solution where if you have like many activities or child work or whatever in your code, and you catch yourself always doing try catch, and to do this fallback and recovery type of stuff, you could maybe use this code and use this method. But basically, it's a util method that takes in two functions. One is the function to be recovered, and the other one is the actual activity function that needs to be invoked. And if the invoke activity fails, as we see activity failure, we're actually going to return the result of our recoverable activity. So long story short, the way you can actually use this in your code, I have to look at the implementation, is something like this. You basically say recover utils try recover, you give it activity recover, which is our activity function that needs to be invoked. And I look at the activity input. So this one is going to be called, which is just an activity method. And then the second parameter is the actual activity that we want to invoke, which is activity execute. This is the activity method that we want to, if this one fails, we're going to call recover. And it's just a small utility method, but just to let you know, since, temporal workflows are written in code, a lot of times when you catch yourself repeating your code, repeating a lot, just use programming language stuff. Just write some util methods that probably can make your life a lot easier. And maybe this is one that can do that. And just to kind of run this guy, and in this case, what we're doing is, wait, where is the activity implementation? We are failing the exec, so we're throwing an MPE here, and our little utility is going to say, okay, I got an activity failure. We can still catch it as an MPE getting from our activity method here. And then we ran the recover activity, and we were able to get the result and still maintain the original failure that we might want to, our recovery method might want to know what the failure was in order to figure out what to do in the recovery of the of your business logic. All right, so any questions so far? No, I see you guys are doing stuff in chat. All right, so this one should be fun. A lot of questions come in, like, for example, pipelines. In order to talk about this, is basically we have to start talking about rate limiting. And the use case for this particular pattern is where you want to start like X number of workflow executions async. So you basically start them at the same time, but you want to assure that these workflow executions happen one at a time. And, pipeline could be one use case, another one, it could be whatever, some other use cases. But long story short is we need a pattern for this because, and we'll talk about when we talk about rate limiting here in a second. And let me go to chapter 4 and see what I have for this real quick. All right, so if we look at actual SDK rate limiting kind of knobs or configurations, the one that actually comes to mind is in worker options. So when you create your workers that actually host and execute, your actual business logic, your workflow and activities, you can define worker options. Now, this is only rate limiting looking at the SDK. Of course, you can rate limit the temporal front-end service. You can rate limit a whole bunch of different things. But worker options kind of do two things. They have kind of configurations. They're based on that also tell the server what to do on a task queue level, but also deal with this on the worker level as well. And the kind of four that come to mind is max worker activities per second. Go ahead. Anybody have a question? No. Which is the number of activities started per second by this worker. The default is unlimited. Now, just note this is for activities. Max concurrent activity execution size is the number of basically concurrent pull requests on the activity task queue. And it's a worker specific limit on parallel activity amount. Then we have max task queue activities per second, which is managed by the server. and controls the activities per second execution for the entire task queue across all of the workers they're actually listening on this particular task queue. So again, if we look at this particular rate limiting options, it is specific to activities. And also we have one, which is called mass concurrent workflow task execution size. Now, wait, this is not talking about activities. But if we look at, we are actually only controlling workflow tasks and not workflows. And this is actually useful, this particular config, which can help you limit CPU and memory utilizations of your workers. So if you have, basically you can slow things down, but you cannot basically with rate limiting alone or some sort of configuration, say I want to start 10 workflows and I want them to execute one at a time. So we can actually not limit the concurrent, workflow executions. So what is the pattern if you ever actually want to do something like this? And the pattern is basically says have one running workflow. So you have one workflow that's always running, and we'll actually look at the implementation of what this looks like. And instead of actually from your client starting your workflow executions like you would with, let's say, a type to run type stub, instead you're going to send signals to this workflows. And each signal payload is going to contain information about the workflow you actually want to start. And this in particular, this implementation of our starter quote unquote workflow, we can actually keep adding our signals to what we'll see here, a list or a queue, and handle these signals one at a time and sync invoke this particular workflow. So let's take a look just a little bit on what this code looks like. I think this is, yeah. So let's, we have a custom object model called toInvoke, which has, let's say, a workflow type, workflow ID, and input. Our starter is going to start our quote unquote starter workflow that has to basically live forever. And it's going to send it 30 signals. And each time it's going to tell it, I want to invoke a child workflow of type my child workflow. I'm going to give you even a workflow ID. You can set it some input or whatever. So basically our workflow implementation is going to have a signal method called toInvoke that takes in a toInvoke object. It's going to add it to an invoke list. Basically, so what this means is we can send hundreds of signals to this workflow, but in our workflow method, we are going to wait until this list is empty, or we send some exit signal to this. That's fair too, and we're only going to take remove the first element of our list, and then we're going to execute a child workflow sync. So this list can grow independently of, and we will still be able to execute our child workflow sync because this child workflow stub.execute, this is a type stub. So the line 41 is a blocking call until the child workflow completes or fails. In this case, we don't have the error handling, but yes, here you could catch a child workflow failure like we've shown before. Now, this is all cool and great, but the problem again is we talked about signals being recorded in history. So let's say, this workflow, since it's long running, is going to eventually, let's say we want to start, 60,000 workflows this way and run them one at a time. It's going to run into issues with the 50K max history limitations. So this particular workflow has to call continue as new. Which means in this case, what we have is some max calls amount, which is for the demo set to 8. So what we're saying basically after 8 child workflow invocations, in your case, it could be, let's say 100 or 1,000 or whatever you want to be actually doing, we have to call continue as new, and we pass it in the current list. Because since our signals can be received independently of not one at a time, but basically we can send 10 at a time, in order not to lose any of the information or the list of child workflows that we have to execute, we can actually pass this list to the next workflow execution using continue as new, which will become the input to this particular next run of this method and be able to handle those signals. So just, what did I change here? I don't think I changed anything. Oh, okay. So let's go ahead and run this thing. And we'll have, let's see if this works. Try or recovery. Oh, I'm running something else. Sorry about that. Run. Let's see. Oh yeah, I needed to run this guy. All right, sorry about that. All right, so we are in child workflow, invoking one child at a time. And after 8 of these things, we're going to call continue as new. So here we handled 8 signals basically from our list of 30. And after 8, our workflow was able to call continue as new and then keep handling our signals that we're receiving async from our client, and able to handle another 8 in this case, or whatever max limit, call continue as new in order to avoid history size, a large history size, or the 50K limitation. And we're able to execute all our child workflows in this way, one at a time. Any questions about that? No, yes, no. All right, let's see what else we have. 1 or 2 more. Oh, okay, so the last pattern that I kind of wanted to talk about is this busy loop with wait. And this comes up a lot where, let's see, I think this is C4. Okay, so, all right. So often we catch ourselves writing this particular code. Because we use programming language, this is kind of what we're used to do. We have a while loop that basically we loop until some condition becomes true or false, basically. And then we, let's say, call some sort of temporal SDK API. In this case, we just sleep, or we can call an activity or a child workflow or whatever. And this is very valid, but there is one problem with this particular busy loop implementation here, is that it grows history. And just to kind of show you this, we're going to run the starter. Let's go to our web UI. Oh, this thing is still running. Terminate it. And all right. So our busy loop, as you can see, is for each iteration, we're going to have a bunch of events. Number 1 is the workflow task started. So we're going to start a workflow task. We're going to create a timer, which is equivalent to our workflow.sleep, right? Then we're going to wait until the timer fires, which is the 500 milliseconds. And then we're going to get to the next iteration, block again on workflow.sleep, and so on. So we'll see repetition. So you'll see that our workflow history using the busy loop actually keeps growing and growing. And the longer you're actually running this type of loop, where you have, let's say, a while, some condition, and you start calling temporal APIs that actually block workflow execution and write things into history, you can see where you can reach the history size can actually become large very, very quickly. And in this case, I think we're actually setting this, I don't know, like maybe for 2-3 seconds. But if we let this run for like 3 hours, you can tell, this busy loop is going to pretty much fill up our history. So a lot of times, and this comes, with experience, with reading docs or whatever, we have actually temporal APIs that can handle this type of busy loop using built-in functions. For example, we just here have a workflow await. And what workflow await does is it's actually going to, wait until some condition becomes true. And in this case, is completed becomes true from our starter when we send a signal to it after 10 seconds. So let's try to run now, instead of our busy loop here that we have here, let's try to use workflow.await and see the difference in workflow history for this particular, using workflow await. All right, so let's see. As you can see here, we basically have, we're at workflow await right now, and our history is not growing regardless of how, and we have actually completed. So once we receive the signal, the workflow.await is going to be reevaluated. At that point, is going to say, okay, this condition is true, and is just going to get unblock and return the result. So you see the difference. We still, in the previous one here, we had, you know, a lot more going on within in the history. So basically, long story short is there's a lot of little things and like that where using temporal built-in APIs can help you avoid. Of course, your code can execute correctly, but using temporal, you know, things like await, like different things, can also help you, you know, with other things. For example, like, you know, history and things like that as well. Any questions about this? No. All right, I think we got
Yes, one
Go
quick
ahead.
question. Can you show the loop again? The code. So in those lines, you really have a loop and you do something within the body of the while loop. If you have workflow await, where are the possible executions that you do in the loop up there? You see, just in line 21, you just wait and then you do something, but you don't do anything in a loop. You don't repeat yourself. You just wait for some Boolean or anything to be true.
Oh, but you can do the same thing here. You can basically, you know, even loop here and wait for a condition, and maybe after 10 conditions, you can, how do you say, call some activities. But the difference is still going to be as far as, how do you say, history goes, is that workflow.sleep is going to have the timer created, timer started, and new workflow task, where here you would basically not have that at all. But yeah, in some cases where you want to wait for a condition to become true, run something, set it to false, and wait for it to become true again, I think you would have to in some way use some looping structure in your workflow code. It's just still using workflow.await is, in my opinion, you know, is better for this case. But you know, if you just want to, you know, write this code just to sleep for 500 milliseconds, check it again, sleep, check it again, then in this case, workflow await makes much more sense to use, right? This is basically optional. Does that make sense?
Okay. Just the simple example would be an email, a reminder email, which you send every day, for example, indefinitely, and so you cannot just have the workflow await structure, right? You would have to wait for 1 day. Then if it's not verified, the email or something, then you have to send a reminder mail again and again until it is verified, for example.
Yeah. In that case, you know, yeah, you can use that. You can use activities. Actually, you can use that polling thing that we showed, which probably makes more sense. This is basically just like, you know, simple busy loops that you might have in your code and how to get out of it, yeah, easier.
Okay.
But yeah, I think for your particular use case, you know, I would probably, you know, look at maybe polling, or we also have an updatable timer sample where workflow.await also takes in a duration, I think. Let's say 5 or something like this, where you can also say how long you want to wait. And we also have samples where we have a loop with workflow await, and you can update this timer as well via signal, for example. So I think there's different solutions, again, using these temporal SDK APIs that can come in handy, and we can figure out what makes best for, you know, what works best for your code.
Okay, thanks.
You're welcome. I feel I didn't answer your question, but sorry about that. All right, so where are we at? All right, so, okay, so finally we get to this SDK metrics. And for temporal, you have two types of metrics. You have server metrics, which, and also SDK metrics. We're not going to talk about server metrics, but I do want to show, let me see. And I'll share this in chat as well, is this GitHub repository. I just call it my temporal Docker compose. We do have a temporal Docker compose repository, which includes, a bunch of little Docker compose files. The only thing that it doesn't contain right now is it doesn't enable SDK metrics. I mean, server metrics. And it doesn't start up it doesn't really, basically it doesn't start Prometheus, it doesn't start Grafana and things like that for you. But if you're trying to run this sample locally, make sure you get this repo, because what this Docker compose does is it still uses the auto setup image, which is not, whatever. So it's not production ready. This is more for local machine. And, you can use on Docker, you can define a Docker compose file to actually deploy each temporal service as its own container. So this is still going to use the auto setup image. But what it does, though, is it does enable us temporal server metrics. So it does set the Prometheus endpoint to port 8000, and exposes that port here. But another thing that it does is sets up Prometheus, and we'll show the Prometheus scrape config as well for you. It sets up Grafana, and it sets up default dashboards as well. So if you run this Docker compose up on this particular file, you will, basically have things running. Now, one thing that I wanted to show is under deployment, we have Prometheus and Grafana. So let's take a look at the Prometheus scrape config. And what this basically says, I'll make it a little bigger if that's okay, is we set up two things. We have set up server metrics. So in this, we use host Docker internal 8000. This is where our temporal server is going to provide or push our metrics to. And we set a Prometheus scrape config for that. And for the SDK metrics, we basically have two ports, is 8077 and 8078. And so those are basically two scrape points from which we want to get the server metrics. And the reason for that is that one is for our workers, and one could be for one or many of our quote unquote starters, or the client that actually starts workflow execution and does the gRPC communication with the front end service to signal with start, to start workflows, sync, async, or whatever. Let me just make this smaller. Another thing that's included here for you is under the Grafana, we do have the dashboards directory. Here we have two dashboards. One is the temporal JSON, which is kind of like the server dashboard, which is still being improved, but there is an SDK.json here, which is an out-of-the-box SDK dashboard, and we will take a look at it, don't worry. Basically for the Java SDK. Currently, there's small differences between, let's say, Go and Java in terms of metrics, how they're actually exported or produced to Grafana. It's not a lot of changes. So creating, let's say, an SDK-Go or SDK-TypeScript would be maybe 10 minutes to do. But just letting you know that if you're using this, the SDK dashboard is particular to the Java SDK currently. So just to kind of show you this in action, we can see our Prometheus scrape points. We are scraping already from the server metrics, but we're not yet scraping SDK metrics, because those endpoints we actually, we will take a look at code here in a minute and start looking at it. And at the same time, we can look at our Grafana, which gets set up, and we can look at the dashboard. For example, here's the server metrics dashboard that you get out of the box. But again, these are server metrics and not something that we're particularly interested for this particular workshop. If you guys are interested, we can actually, make sure that we create this as well. Okay, the statsd Datadog. Yeah. Were you the guy that asked the statsd question on the forum?
No, that wasn't me, but I know this is a popular question. We're heavy
okay.
Datadog users here and would love it, but yeah, we're working on it right now.
No problem. But yeah, there was a recent question about statsd exporter and different format. It uses dots instead of underscores, I think. And there was a question on how to consume that in Datadog. But if you can help out on the forum for that, I would rock too. You don't mind. But anyway, so back to the code, back to our last section is in the Java SDK samples, we have a metric sample, and this is more or less a copy of that. But I just kind of wanted to show in order to enable metrics, you have to set them via workflow service stub option. So when you create your service or your workflow service stubs, basically, you give it workflow service stub options. And in here, there is a config called set metric scope, and you can set the metric scope here. What we use here is a Prometheus registry. We do have an Uber tally scope that we have to create. Now you can set your custom tags here. So every single metric produced by the Temporal SDK is going to include this particular tags, which is currently constant. It has a key and a value pair, basically. And you can set a reporter, which in case we use a micrometer stats reporter, and we report, let's say, every 1 second in this case. Now, what we are doing is, because the server has its own kind of HTTP thing going on where it can, as you've seen on, well, actually, let me show you. If we go back to here, you can actually see your server metrics exposed on port 8000. And this is handled by the server once you enable server metrics in your Docker Compose file, for example. But for SDK metrics, we do create for this the sample HTTP server, and we're going to push it, our metrics to this particular server. And again, the ports here, 8077, and the same thing on the client where that does the gRPC calls, we have 8078. These are the Prometheus scrape points that we have defined in our config that Prometheus is going to start scraping our SDK metrics from once these endpoints are up and running. So that can be down, and you can start your applications, and this thing will pick it up and run with it. So anyway, so let's go ahead and run this thing. So we're first going to start our worker. Our worker does have the metric scope enabled, which will allow us to get the SDK metrics that the Temporal Java SDK pushes from on the worker side. And then we're going to start well, let's take a look at that first. So here is our endpoint that is going to contain our metrics that come from the workers. And in this case, let's run a starter. And our starter is going to run some workflows. It's going to first run a workflow that has like some activity retries that where activities fail. And then it's going to start running like 40 workflows that just take a while to complete. And then it's going to start running 40 workflows that basically fail. And that's this particular starter, just so we can go ahead and take a look at the metrics and see what's going on here. Anyway, so when we do the starter, we can go back to our Grafana dashboard, which is all the links are here if you use this Docker Compose. And we can, on the home, we can go to the Temporal SDK metrics. And let's see if I can change this. All right, so this is just starting. So, it takes a little bit for this data to fill up. And we'll refresh this page in about a minute or two when actually we have some data that's going on. But long story short is you have the, in this particular dashboard, you have the RPC overview, which is the remote procedure calls that happen from your client applications to the temporal server front-end service. So you can do like request failure, blah, 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 and things like that. This dashboard also includes things like workflow information. So you can have workflow completion graphs. You can have workflow end-to-end latencies, success, workflow task end-to-end latencies, and we'll see if something is going on here already. Workflows failed by type, which this should be also populated once we have some data going on from the starter, and things like that. You also have activity information in this dashboard. For example, activity throughput by activity type, failed activities by type, execution latencies, end-to-end latencies, and all these different things that the Temporal Java SDK, the metrics that it provides for you. Now, and while this is actually, I'll refresh it in a minute, I wanted to go back here and make sure that I put a link here to this worker tuning guide that Dimitri wrote and is in our docs. This is a very important page in our docs. And you can actually see if you want to use this dashboard or a similar dashboard that you build yourself to tune the performance of your, let's say, workers and the applications, the temporal applications that you're running. It does show some most important metrics, and you make sure. And so basically, those are workflow tasks scheduled to start latencies and activity scheduled to start latencies. And in addition to that, this doc has a lot of really cool information about, how to fine tune your workers and things like that to get the best performance as far as, your applications go that run on Temporal. So let's go ahead and see if this has actually changed. Yeah, so we're getting some more data as our workflows are running. And let's see, under workflows, we have some completion. So we completed, let's say, our fill workflows, a bunch of them, metrics workflows, things like that. Let's say our fail workflow has actually failed, and a number of them too. So you can see that, you can also build in alerts and things like that, and whatever you need. But it is fairly easy to get started with SDK metrics, and hopefully, this particular simple Docker, compose can help you get started. And another thing that this thing does is, if you guys care about, is, and I will show this, is the WebUI v2. So far we have shown also only WebUI v1, which is being decommissioned. We do have a v2 that's available, and I think currently it's not production, I guess released, but our guys are working on this and doing a great job with it. I just simply didn't, have time to test all the workflow histories in this yet, but going over for the next workflows, we will start using WebUI v2, and it has a lot of colors. It has awesome features and things like that, that hopefully will make it simpler to look at workflow history and figure out bugs or whatever you guys need.
Actually, Tiha, I think that you just didn't update your Docker Compose. I believe right now by default it's this v2 already there.
Yeah, of course. Yeah, in this guy, what I have, I think I'm running both. So I have temporal web, and I have temporal UI. So yeah, and always check if you do end up using this one-off repo to check the latest v2 or temporal-UI version available, and update as well. Yeah. Let's see, do we have anything else? I think we're done for this workshop, honestly, and I'll stop sharing my screen. Any final questions? Anything you guys would like to see for the next workshop? Anything that we didn't cover that you would like to talk about? Anything is fair game.
If it's still possible, could you go over the metrics again, maybe just to show the most basic metrics that you would use, like a pending activity, or which never comes back, or something like metrics like a heat map, like where's the bottleneck in the workflow, how to see this in the metrics.
Yeah,
This would be
definitely.
interesting.
I would first of all look at this temporal worker tuning guide. And the one thing to start off with, and I actually like this, we should actually have a workshop just on this and actually look at every single metric. Unfortunately, the starters that I created or the workflows that I'm running do not really put the worker to a limit where I could actually easily show some sort of issue and then a fix for the issue, basically, we could create starters and put the worker to the limit where we can actually alert on something and then try to use some configurations or rate limiting to lower things down or to help with things. But basically, I think the two metrics that we have to look at is workflow task schedule to start latencies. And I think I use them here under workflows. I think they are workflow throughput. And let me make sure that I'm actually using them here. Yeah. Oh, this is task queue pulse.
May I also just give like a little bit of comment here?
Yeah,
So Patrick, it looks like you're asking about pretty granular things, especially like heat maps about which parts of workflow are slow, etc. We definitely don't go that deep into metrics right now. So this worker tuning guide is like, I think 2-3 months written like 2-3 months ago, and even just to make that possible, I needed to make new metrics that became a part of Java SDK 1.8, I believe. And that metrics are fairly high level. They're basically just reporting, for example, an amount of available executors. And we don't provide right now very good metrics for a small granularity thing. For example, like one of the things in our mind right now that we need to provide a metric that allow you to detect a situation when one activity keeps failing. For example, like we have a metric for activity failures, but we don't provide a good way to detect that general level of errors is low, but there is, for example, one activity that stacks and keeps failing. Or, for example, one workflow that stacks and keep failing. So this level of details right now, some level of these details are just uncoverable with metrics at all. For example, I don't think we ever will be able to provide like a heat map of workflow execution in metrics format. But some things we are going to get better, but we are not there yet. So just keep our metrics, our metrics will get better and we are actively working on that, but we are not there yet.
Okay, thank you. I mean, there are already a lot of metrics, so
yeah.
I just started looking into them because we're close to going live with that. So we need some metrics, and I mean, out of the box, there's plenty of stuff already.
Yeah, there is. That's the actual problem. We already have way too many metrics and we are not there yet. So we kind of try to keep this balance of keeping things relatively simple and manageable, because if we try to produce metrics for absolutely every failure scenario, every instability, we will just spam you with metrics that will be unusable because you will not be able to discover the one that you need. But in general, metrics for SDKs are, there is a worker tuning guide one, and I don't know if you saw this, there is an SDK metrics page, which gives a description for all important metrics. So give them a shot. If you, especially if you didn't see them yet. Sorry for interrupting.
Maybe just one last question. Is it also possible to like define custom metrics that are more like on a business level, so that I like
yeah, of
custom
course.
search attributes and yeah.
Of course, you can, in your workflow code, in your activity code, you can make workflow dot or activity dot or activity context dot get metric scope. And you can get metric scope and you can log your own metric. For example, how much time it took to travel between 2 points or whatever. So you can produce your own custom metrics.
So for example, here, if you can see the screen, we're actually inside of our activity that's retrying. We're using the activity context metric scope, and we're actually adding our custom metric activity retries and increasing about 1 for each of the retries this activity is doing. And you can do the same thing in, like Dimitri said, in your workflow code as well. So you can do, like, for example, here, workflow.get metric scope and counter and blah, blah, blah here as well. And I think this already also showed that how you can do custom tags as well, right? We already shown that in the starter, I think up here. Yeah.
Okay, that's
And
perfect.
I
Okay,
I just posted into the chat the link to the SDK metrics documentation if you didn't see it yet.
All right, so I think we went over time. I'm not sure, but yeah. Any comments? Any more questions that anybody might have? Any input on?
I see folks asking questions in chat about a resource limiting. I didn't get time to get into the question. You can ask the question we can discuss right now, or you can reach me offline in Slack, whatever you prefer.
All right. Well, with that, I mean, yeah, I want to thank you for being here. And yeah, we'll do another one of these probably in a month or a little bit, maybe 5-6 weeks. And if you have any inputs on what we should cover next time, please drop it in either Slack or yeah, Slack would be best. If you haven't, let us know. All right. Hope you have a great day. Thanks, everybody.